Continuing with example 1, let's write each rational expression in lowest terms. 1c, y squared minus 5y plus 4 divided by y squared plus 3y minus 28. Now, in order to simplify this rational expression, we can't just start canceling right away. Remember, we first have to express our numerator and denominator as products. That means we have to factor first. So let's take our numerator and factor. We have y squared minus 5y plus 4. Hopefully you're getting really good at factoring by now. Y squared minus 5y plus 4 factors as follows. Y minus 4 times y minus 1. Negative 4 times negative 1 is 4. Negative 4y minus y is negative 5y. If you use a chart to set up to get this, it'd look as follows. Now let's factor our denominator. We have y squared plus 3y minus 28. Again, hopefully you're getting really good at factoring. And when we factor this polynomial, we'd achieve the following. Y minus 4 times y plus 7. You can check it. Negative 4 times 7, negative 28. Negative 4y plus 7y is plus 3y. And again, the corresponding chart would look like this. 1's in your first column, and 4 and 7 in your second column, with the negative being on the 4 to give us negative 28. Perfect. So now we have factored our numerator and our denominator, and the next step is to cancel any common factors. Notice y minus 4 appears both in the numerator and in the denominator, so it can be reduced to 1 over 1. This leaves us with the remaining two factors, y minus 1 in the numerator, y plus 7 in the denominator. They are not the same, they're different terms, so we finish by boxing this answer. Y minus 1 over y plus 7 is the reduced form of y squared minus 5y plus 4 over y squared plus 3y minus 28. Example 1d. Reduce 3x squared plus 13x plus 14 divided by 3x squared minus 5x minus 28. Now, as with our previous example, our first step is to factor both the numerator and the denominator. So let's start with our numerator. 3x squared plus 13x plus 14. Now this one's just a little trickier than the previous one because it has a number in the front, but we can still handle this. 3x squared plus 13x plus 14 factors as follows. It's 3x plus 7 times x plus 2. We can check that by multiplying out. The 7 times 2 is the 14. 7x plus 6x is 13x, and 3x times x is 3x squared. If you want, the chart or the box that would correspond to this would be as follows. 3 and 1 being the factors of 3, 7 and 2 factors of 14, 3 times 2, 6, 1 times 7, 7, and 7 plus 6 is 13. That's where you had the 3x plus 7 and x plus 2. Let's similarly factor our denominator. We have 3x squared minus 5x minus 28. This factors as the following: 3x plus 7 times x minus 4. Again, if you want, this would come from the box as follows. 3 and 1 in your first column, 7 and 4 being the factors of 28, with a negative on the 4 to make negative 12, and 7. Our numerator and denominator factor as 3x plus 7 over x plus 2, divided by 3x plus 7 over x minus 4. After we've factored, what's our next step? Our next step is to reduce. How do we reduce? We reduce by canceling the common factors, and in this case 3x plus 7. 3x plus 7 divided by 3x plus 7 is 1, and that will leave us with, in the numerator, x plus 2, and in the denominator, x minus 4. These are not the same factors, so we can't cancel any farther. That means this expression reduces to x plus 2 over x minus 4. Example 1e. Write the rational expression in lowest terms. 9 minus b squared over b minus 3. All right, now let's take a look. First we start with the numerator, 9 minus b squared, and we want to factor that as far as possible. 9 minus b squared is actually a difference of squares. 9 is a square, a perfect square, 3 times 3, and b is a perfect square, b times b. So we can rewrite this, if you recall, as 3 minus b times 3 plus b. In the denominator we have simply b minus 3, and that can't be factored, so we'll simply write b minus 3. Now let's see what we can cancel. Well, 3 plus b and b minus 3 are not the same because we have a different sign here. But notice here we have a 3 minus b and a b minus 3. These are almost the same, but they're not exactly. They are, however, multiples of each other. Let me explain a little farther. Let's analyze this situation. Alrighty, let's suppose that b was 8. We would have 3 minus 8 over 8 minus 3. The same terms, 8 and 3, but they're reversed, the order that they go, but a subtraction is in between each one. Well, 3 minus 8, that's actually negative 5. 8 minus 3, that's actually positive 5. They're negatives of each other, and when you cancel negative 5 divided by 5, that gives us negative 1. Well, let's try another number. Let's try 3 minus 13. And let's do 13 minus 3. Same two numbers, but reversing the order. 3 minus 13 is negative 10. 13 minus 3 is positive 10. Again, the same numbers, but they're different signs. Negative 10 divided by positive 10 is negative 1. In fact, no matter what two numbers you put, when you reverse them and put a subtraction between them, so let's say 5 minus 9 divided by 9 minus 5, the result is always going to be the same. You're subtracting the same values, but one will be a positive and one will be a negative. 5 minus 9, negative 4. 9 minus 5, positive 4. They reduce and give you negative 1. This is always true, and this creates a rule. If you have a minus b over b minus a, and you want to cancel them, your result will always be negative 1. Always, always, always. So that tells us that we can apply that rule here in this problem. 3 minus b divided by b minus 3, we can cancel them, and the result is actually negative 1. 3 plus b stays, and so when we simplify this down, the answer is negative 1 times 3 plus b. We don't have to write the denominator because it's just 1. We could leave our answer like this, or we could rewrite it by multiplying in the negative 1. Negative 3 minus b. We finish with example 1f. Reduce the rational expression 7x plus 1 divided by 7x minus 1. Now our first step would be to factor both the numerator and the denominator. 7x plus 1 doesn't factor any farther, and neither does 7x minus 1. Can we cancel anything? Well, notice you might be tempted, but you cannot cancel these 7x's. Why not? because they are not part of a product in the numerator. They're part of a sum and a difference, so they cannot be canceled. That means that our answer is already reduced to its lowest terms. 7x plus 1 divided by 7x minus 1 is simply reduced in lowest terms. Before I summarize the video, let me just end by doing a further explanation of why 3 minus b over b minus 3 equals negative 1. Now, for those of you that are not interested, you can just skip this part, but usually or generally, I'll have at least 1 or 2 students that ask me why this is so, or can you explain it a little farther? So let me do that right now. Notice 3 minus b actually is a polynomial, and it can be factored farther, even though you might not think so. What do I mean? Well, let's reverse the order of the terms. 3 minus b is equivalent to negative b plus 3. Those two are exactly the same. And if I look at 3 minus b as negative b plus 3, notice I can take out a number from both the first and second term. I'm going to take out the lead coefficient on b, which is actually negative 1. So when I factor out a negative 1 from that lead term negative b, it leaves me with b. And when I factor a negative 1 from a positive 3, it leaves me with a negative 3, because negative 1 times negative 3 is positive 3. Now on the bottom, we simply have b minus 3, which I'm going to leave alone. But once you've factored out that negative 1 from the numerator, now it's crystal clear how things cancel, because now the b minus 3's appear clearly and they cancel, and it leaves you with that factor of negative 1. So that's just for people that might just want a little further explanation of why this 3 minus b over b minus 3 is equal to negative 1. And like I said before, it's true for all numbers. A minus b over b minus a always simplifies to negative 1. Let me state again that in order to write a rational expression in lowest terms, we first completely factor the numerator and the denominator, and then we use the fundamental property of rational expressions to reduce any common factors. Good luck and have fun!